Physics part 45. To do this, we draw tangent to the curve of the figure at regular intervals of time and measure the slope of each tangent to obtain the values of v velocity. The plot of v against t gives the graph in from 0 to maximum value and then decreases to 0 again. We will look at this example in more detail on our oncoming content of this tutorial, where we shall see the area under the velocity. Time graph in our figure gives the displacement of x. Now, what is acceleration? We have used the word accelerating. Acceleration means describing the increase in velocity of the car in previous section. Acceleration is a measure of the rate at which the velocity of the particle is changing. Average acceleration is defined by the world equation. Average acceleration is equal to change in velocity over time taken. The unit of acceleration is the unit of velocity, the meter per second, divided by the unit of time, second, giving the meter per second, meter per second, seconds power raised to -2. In symbol, this equation is average acceleration is equal to v2 minus v1 divided by t2 minus t1 is equal to delta v over delta t, where v1 and v2 are the velocities at time t1 and t2 respectively. To obtain the instantaneous acceleration, we take extremely small time intervals, just as we did when defining instantaneous velocity. Because it involves a change in velocity at a vector quantity. Change in velocity is a vector quantity. Acceleration is also a vector quantity. We need to specify both its magnitude and its direction. We can't deduce the acceleration of a particle from its velocity. Time graph by drawing a tangent to the curve and finding the slope of the tangent. The figure shows the result of doing this for the car's motion described by the figure. The displacement minus time graph and figure velocity time graph. The car accelerates at a constant rate between O to A and then deaccelerates, that is, slows down uniformly between A and B. An acceleration with a very familiar value is the acceleration of free fall near the Earth's surface. We can find it on the oncoming part of this tutorial. The fall to the Earth's surface is 9.81 meter per second, seconds power raised to -2, often approximated to 10 meter per second, seconds power raised to -2. The exact figure is of course 9.81, but usually they round up to 10 meter per second, seconds power raised to -2. To illustrate the range of the values, you may come across some accelerations which are summarized in our table. They are very interesting. They can certainly give you a lot to understand. We talk about the car crash, family car, free fall of moon at equator, circular motion of electron around nucleus, and we certainly give you some very interesting details and give you the figures on their acceleration per second.